Okay, functions and relations. Okay, so everything that we dealt with so far, all those graphs that we dealt with at this point were relations. Some were functions, but all were relations. By the way, all are relations. Some were functions. So let's talk about what a relation is. A relation is a set of ordered pairs. So a relation is a set of ordered pairs. So all those graphs that you did, that you graphed, those were relations. So for example, when you graphed y equal 2x minus 3, that line, that was a relation. Remember in the first test you had to graph a line? Why on that first test was that a relation? Because when you graphed it was a set of ordered pairs, wasn't it? So when you graph a line, and that's not the graph of this one, but when you graph a line, isn't a line made up of a set of ordered pairs? Mm-hmm. Okay. You also graph something like this on that first test. I'm just making this up. Something like this. That was a relation as well. That was a quadratic, right? So your parabola. Why is this a relation? Because it's made up of a set of ordered pairs. Okay, so a relation can be represented by an equation. A relation can be represented by a graph. A relation can be represented by a set of ordered pairs. So for example, this is a relation right here. The set that has, let's say, 5 ordered pairs. Just a finite set. So this is a finite set. Let's just do this. So all these are relations. All these relations. Because all of these are represented by a set of what? Ordered pairs. Now, these 4, how many ordered pairs are there? An infinite number. So this relation has an infinite number of ordered pairs. This relation has a finite number. Finite meaning you can count. How many are there? 4. There are 4 of them. So it's a finite number. So it's a finite number of ordered pairs. You could also represent a relation using that t-table. When we did a t-table, that's a relation. 2, -5, 6, 3, 0, 4. Those are all relations. So anything represented that represents a set of ordered pairs is a relation. Okay?
And a set of ordered pairs is 2 points on a plane.
Yeah, it's an x, y. I mean, it's a point. An x coordinate, y coordinate.
I'm making my notes as like.
Let's talk about a function. A function is a special kind of relation. A function is a special kind of relation. And here's the definition of function. For each x coordinate, there can only be one exactly one y coordinate. So a function is a relation in which for each x there's exactly one y. Okay? So let's look at this definition in terms of finite sets for right now. So let's look at this relation. So determine if each relation is a function. Determine if each relation is a function. Now again, we're going to look at only the finite set for right now. So number one, let's suppose I had this finite set and it has these points, these ordered pairs. 2, -1, 3, 2, 6, -5, 4, 5, and let's say 0, 8. All right, so go ahead and write this down. So you have this relation, and this relation has how many points?
5.
5. So I want to know if that relation is a function. Well, according to the function, it says that for each x coordinate, there's got to be how many y coordinates? Just one. Now it helps if you look at this relation when you have a finite set. It helps if you look at this in terms of a mapping. A mapping. So in other words, you're going to draw something like this. You're going to draw 2, just like a T-table, although it's going to be like 2 ovals, like this. And by the way, let's go ahead and talk about this now. And we did before. We talked about this before. Your domain is a set of which coordinates? X's, and your range is a set of which coordinates? Y's. So remember, your domain is a set of x coordinates. And your range is a set of y coordinates. So when I do the mapping, when I draw the mapping, this will be my domain, and this will be my range. Sometimes you'll see these words instead. You'll see input and output. You'll see those words also. Input, output, domain, range. So remember, your domain is a set of x coordinates. So when x is 2, what's my y coordinate? -1. So I'm going to write it. So 2 gets mapped to -1. 2 is associated with -1. 3 is associated, gets mapped with 2. 6 gets mapped with -5. 4 gets mapped with 5, and 0 gets mapped with 8. All right, now let's talk about function. Function says that for each x coordinate, you had to have exactly how many y coordinates? 1. So when x was 2, what was my only y coordinate? When x was 3, what was my only y coordinate? When x is 6, what was my only y coordinate? When x is 4, what was my only y coordinate? And when x is 0, was my only y coordinate. So is this a function?
Yes.
Yes, so this is a function. All right, because for each x coordinate, there's exactly one y coordinate. All right, number 2, suppose you had this. Let's say you had -1, 6, 3, 5, 0, 2, -4, 6. Let's say that this relation had 4 points instead. So I need to determine if that's a function or not. So what do you think? Based on the definition, for each x coordinate, there's got to be one y coordinate. Is this a function, not a function? Okay, some of you say not a function, some of you say it is a function. So let's look at this in terms of the mapping. Remember, the definition says that for each x coordinate, there's got to be exactly one y coordinate associated with it. So when x is -1, what's my y coordinate?
6.
6. So 4, we're good, right?
Yes.
When x is 3, what's my y coordinate?
5.
So 4, we're good. So 4, it looks like a function. When x is 0, my y coordinate is 2, right? when x is -4. Now remember, if the value occurs more than once, only listed once. So when x is -4, I already have 6 listed, so I'm just going to draw an arrow to 6 here. But listen to definition. Definition said for each x coordinate, there's what? 1 y. So when x is -1, there was 1 y. What was it? 6. When x is 3, there's only 1 y. What was it? 5. When x is 0, there's only 1 y. What was it? When x is -4, there was only 1 y. What was it? 6. Is this a function or not a function? It is a function. It's a function. For each x coordinate, there's what? 1 y coordinate. We just talked about that. When x is -1, how many y coordinates were there? 1. So basically, you can have the same y value for multiple x's, right? That's fine. I mean, you could have had this, guys. I'm going to ask you this in number 3. Is this a function or not a function? Listen carefully. And let's say they all get mapped to 5. Is that a function, not a function? It is a function. Why? Y'all getting confused. For each x coordinate, there's what? 1 y. So when x is -4, there's only 1 y. What is it? 5. When x is -3, there's only 1 y. What is it? 5. When x is when x is 2, there's only 1 y coordinate. What is it? 5. When x is 0, there's only 1 y coordinate. What is it? 5.
So if we were to
so-
say that x is 5.
Hold on. We're getting to that point. You just hold on. So these are all functions, right? These are functions. Now, let's suppose we had this, number 4. -1, 5, 2, 6, 3, 6, -1, 7. All right, why? All right, you say it's not a function. What makes it not a function? Because when x is what? When x is what? -1, there are how many y values? 2. So if you look at this in terms of a mapping, you'll see that. In terms of a mapping, look what happens. Domain, range. When x is -1, what's my y value? 5. So far, we're good. When x is 2, what's my y value? So far, we're good. When x is 3, what's my y value? So far, we're good, right? I don't have an issue so far. When x is -1, I already have it listed. It's only listed once. When x is -1, what's my y value? 7. Now, let's talk about this. When x is -1, do I only get 1 y value? No, I get how many y values? 2. So this is not a function because there are 2 y values when x equals -1. There are 2 y values when x equals -1. Okay? All right, so you understand the definition of function? Okay. Now, notice that when our first 4 problems, it was a finite set. It was a finite set. Now, let's go ahead and for the first 4, list the domain and range. So the domain, go back to the first one. The domain is a set, and don't confuse that with what you put on the test for domain and range for the circle. No, that wasn't on the test. That was on a worksheet. On the worksheet, right? For the domain and range of that circle was an interval. Here, it's a set because it's a finite set of ordered pairs. So, and it does not matter what order you put your x coordinates in. So tell me the first x coordinate. 2, comma, the next one.
3,
Next one.
6,
Next one.
4,
4, you write 4, and then 0, right? The range would be what set?
y,
-1, 2, -5, 5, and 8. So next one, number 2. What's your domain here? -1, 3, 0, -4, and the range would be, remember, only listed once only. So it'd be 6, 5, and what? 2. That's it. You only listed once. Number 4, well, let's do number 3. Number 3 was the domain. -4, -3, 2, and 0. The range is only one number. What is it? 5. That's your range. Okay? And number 4, what's the domain? -1, 2, and 3. And the range? 5, 6, and 7. Okay? Again, only listed once. All right, now the handout I gave you, go ahead and take that out. This right here. How many set of ordered pairs does each of those have? An infinite number. So now we're looking at an infinite number of ordered pairs. So again, I want to determine whether the relation is a function, and then also state the domain and range. Okay? All right, so for determining whether the relation is a function, they're all relations because each one's a set of what? Ordered pairs. So if you look at all those graphs, they're all ordered pairs. Let's talk about the differential function. Differential function said that for each x coordinate there was what? One y coordinate. Right? Okay, so listen carefully what I'm about to say. When x is 3, right here, when x is 3, what was my y coordinate? 1. So when x is 3, there's only one y coordinate. What was it? 1. When x is, let's say, 6, what was my y coordinate? 7. So when x is 6, there's only one y coordinate, right? When x is 0, is there only one y coordinate? Yeah. When x is -2, is there only one y coordinate? It's way up here, but is there? Yes. There's an easier way, though, when you have a graph, to determine whether it represents a function or not. And that's to look at this in terms of the vertical line test. The vertical line test. The vertical line test. So remember, the definition of function, for each x coordinate, there's how many y coordinates? 1. So look carefully at this. When I go back to that parabola, and think of this as a vertical line, and notice that this vertical line intersects the graph here, right? For that x coordinate, see this x coordinate right here? Yeah. How many points were on that graph for that x coordinate? 1, right? Yeah. So for this x coordinate, here's my point right here. Y'all agree? Yes. Okay. So you see that where it intersects? So there's only one y coordinate, right? All right. For this x coordinate right here, is there only one y coordinate? Yes. For this x coordinate right here, is only one y coordinate. Yes. So the vertical line test says this. If you draw a vertical line everywhere, and it intersects it once everywhere, then this is a function. Remember, if it intersects it once, that means this. See when I drew it right here? For this x coordinate, whatever that is, it intersects it once here. That means there's only how many y coordinates? 1. So the vertical line test says this. If a vertical line intersects the graph once everywhere, at all places on the graph, then the relation is a function. Then the relation is a function. So if a vertical line intersects the graph once everywhere, then the relation is a function. Make sure you understand it in terms of the definition of function. For each x coordinate, there's only one y coordinate. Now, you should see this in number 2. So in number 2, the circle is that a function or not a function? It's not a function, because you can even see this. For this x-coordinate right here, and let's say that's whatever this x-coordinate is right here. Y'all see this one? There are 2 points associated with it. There's this y-coordinate right here, and there's also this y-coordinate. You'll see that? So if this is your y-axis, that's 1, 2, 3, 4. So when x is 4, what are my y values? There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8, and then that one's -2. So 4, -2. So when x is 4, what are my y values? 8 and -2. Is that a function? Not a function. It's not a function. So in fact, if you look at this vertical line, it enters the vertical line, and all you have to do is find one place, but it intersects the graph an infinite number of places twice, right? So this relation fails the vertical line test. It fails the vertical line test. So it's not a function. Makes you understand why. Because when it intersects, see, it intersects the graph twice, right? So that means that for that x-coordinate right here, there are how many y-coordinates? 2. There are 2 y-coordinates. There's got to be how many y-coordinates? 1. Number 3, function, not a function. It's a function. It's a function. It passes the vertical line test. So it passes vertical line test. So it's a function. What about this one? Function, not a function. Okay, but look right here. This right here, it intersects the graph once. But what's the issue? The other places, right? So all the other places intersects it more than once. So it fails the vertical line test. So it's not a function. Next one, function, not a function. That's a function because it passed the vertical line test. So this is a function. Passes the vertical line test. What about this one? Function, not a function. It's a function. Passes vertical line test. In fact, the next 2 are what? Functions. So these are functions. They all pass the vertical line test, right? Passes vertical line test. So this is a function as well. No matter where you draw the vertical line, it intersects it once. So it's a function. Passes vertical line test. Page 5. Are these functions? Yes. So all these are functions. Passes the vertical line test. Intersects no matter where you draw. No matter where you draw. Where you draw the vertical line, it intersects it once each time. Okay? So all these are functions. All these are functions. Is this one a function right here, the top one? Yes, that's a function. Is this vertical line a function? No. Vertical lines are not functions because notice, if I take that straw and put it over that vertical line, how many times does it intersect that vertical line? An infinite number. So in fact, you can look at this and see that it's true. Because look, when x is -3, because that's what x is, right? When x is -3, what is this point right here? -3 comma what? 5? What is this one right here? -3 comma what? 3? And so on. So you get an infinite number of those. So remember, the definition says for each x-coordinate, there's going to be one y. Here, there's an infinite number. So it fails the vertical line test. So it's not a function. Okay? All right, now, let's go back to that circle. let's go back to that circle and think about what you turned in today. All right, let's go back to that circle and look at what you turned in. All right, this right here. Let's talk about this in terms of domain and range. So, on the one you turned in today, when you talked about, that was your class, right? Okay. When you talk about domain and range, for domain is a set of x coordinates. Now, notice how many points are on this line, on this circle. An infinite number. They're an infinite number of ordered pairs. So here you're talking about an interval. So you go from left to right. So I start touching a graph when I'm at this. I start touching the graph here, right?
Right.
So the question is, what is that x coordinate? Yeah, it's just, okay, so this is your y-axis, right? So that's -1? So you're going to go, domain will be from bracket, not parentheses. Yeah, because there's this point's actually on the graph. So bracket -1 all the way, and tell me where to stop. Do I stop here? No, I stop until I get to the furthermost right point, right here. And let's just guess it to what it is. 5, 6, 7, 9. Okay. All right, bracket. And you always go from smallest to largest. -1 to +9. The range is a set of y coordinates. So you go from bottom up. So I start touching the graph when at this lowest point, right? At that lowest point. But remember, we're looking at the y coordinate. So what is that y coordinate? -2. All the way to what y coordinate? 8. Okay, 8. So there's your domain and range. In number 1, the range is easiest in number 1. Let's talk about the range. Oh, by the way, that was a function, right? It passes the vertical line test. Okay, range, you're going to say bracket what? 1 all the way to positive infinity. Now, this is where we start talking about infinity, positive infinity, infinity, negative infinity. Notice that these are arrows, so it keeps on going. It never stops. So my y value getting bigger and bigger and bigger and bigger, all the way to what idea? Infinity. Infinity. Now, here's what you remember. So this point is on the graph. So what's that y value? 1, bracket 1, all the way to infinity, right?
Right.
Now, remember, infinity is not a number. It's just an idea of something getting bigger and bigger and bigger. It's not bounded. So you're going to say infinity. It's like a sideways 8 with parentheses. So whenever you use infinity or negative infinity, you're always going to use parentheses. Okay? Infinity, negative infinity, you're always going to use parentheses with it. All right? Let's do one more with this, and we'll do the rest next class period. Oh, I forgot to do range. I'm sorry. I forgot to do domain. The domain.
It should be negative.
Okay, now domain. You got to think about your graph. Now notice, you got to visualize this. See, these are arrows, right? Keeps on going like this, right? Keeps on going, right? So I'm going to ask you this: if this number right here was -1,000, is there a y value on the graph?
Well, yeah.
Yes. If this is -1,000,000, is there a y value on the graph?
Yeah.
If this is -1,000,000,000, is there a y value in the graph? Yes. So you're going all the way from where? Negative infinity all the way to positive infinity. So your domain, it never stops, right? So look, if this x value, am I going to get a point on the graph? Does that graph stop? No. So it's going from, and remember, you always go from smallest to largest, from left to right. So you're going from negative infinity all the way to positive infinity. Now remember, we said infinity, negative infinity, you always use parentheses. Just like that. All right, let's do one more. Huh? What's your question?
Domain. So we wouldn't say bracket 3. We wouldn't start at the point on.
Well, there was an arrow here. The arrow kept on going.
Okay.
It doesn't stop the arrow. There's an arrow there, right?
I'm thinking of X, that's why.
No, we are so domain.
Domain's a set of x coordinates.
Okay.
So you gotta look at the x-axis. So you move along the x-axis. The range is a set of y coordinates. You move along the y-axis. So we did the range. This is where it started at 3.
Okay.
So you move along the y-axis. The domain, you should move along the x-axis. So you're telling me that this is where the graph starts right here? No, because remember, it keeps on going. So it's way on this side, which is the idea of negative infinity. Negative infinity to positive infinity. Okay? So when you do this one, what's the range? The range is easy. You go from bottom up. So notice the arrows are pointing down. So is there a lowest point? No. You see this arrow keeps on going, right? So you're going to say what? Negative infinity. Is there a highest point? Yes, right here. What's that y value? 4. So what's your range? Parentheses, negative infinity to positive 4 with a bracket. Okay, good. What is the domain?
Negative infinity.
Yeah, because you remember the arrows are pointing, it keeps on going like this, right? So this is not where it starts. You see this, it starts way on this side. There's no boundary. So negative infinity all the way to what? Positive infinity. So in x, let's say this right here was x is, let's say 1,000,000. Is there a point of the graph? Yes, down here. So negative infinity to infinity. All right, real quick. Let's talk about the domain here. Now put arrows here. Put arrows right here on these. Put arrows. Let's talk about domain. Domain's the easiest to deal with here. So notice domain, guys, domain. When I go along the x-axis, where does this straw start touching the graph? Here. What is that x value? Negative 4. Does it stop? No, because the arrows. So that's all the way to what? Infinity with parentheses. Now, the range. The range is kind of that same idea with the previous domains. These are arrows, right? Keeps on going down like this. Keeps on going up like this. So think you got to visualize that. The range, you go from bottom up. Is there a lowest point?
No.
Because of the arrow, right? So you're going from negative infinity. Is there a highest point? Does it stop here? No, it keeps on going up. So what's the range? Negative infinity to positive infinity. It's not an easy concept. No, it's not. It really is not. It's difficult. But once you see the light, you got it. But it's not. You got to see that light. All right.